Hello. Um, I'm starting with antimatter matter annihilations. So, I've kind of talked about this already, where when my theory is basically that the reason why there's anything is because enough energy basically coalesced, I guess, and because of that, a reaction happened where when enough virtual particles like collided at one time to create enough energy that when one of them hit, like, enough coalesced at one time that when their virtual particle collapse happened, they didn't cancel out. And because they didn't cancel out, there was this little bit of excess energy that allowed the other ones not to cancel out. And because they didn't cancel out, there was this excess energy. And all of a sudden, it went from being a virtual particle to a real particle, as we call it. And so these real particles then caused other reactions to create real particles. And this just was kind of a chain reaction that built on itself onward and upward. And a bit of proof that I can point towards this is antimatter matter collisions, because when like we'll say an electron and a positron collide, they annihilate, right? But here's the thing: annihilation is if they're complete opposites, right? If this is truly matter and antimatter, when they collide, it should result in nothing. There should be no reaction because it is a perfect balancing of forces, right? If you have, I don't know, -3 degrees and just regular 3 degrees, you put those two temperatures in like a space together, they should balance out to 0 degrees, right? And maybe it's not. Maybe I think actually the way the thermal, that may be a misconception, but honestly, all more towards my point. But that may not be the best example. But what I'm trying to say is that -1 and 1 cancel out at 0. So a positron and an electron should result in absolutely nothing. 0. Nothing. No particles, nothing at all, right? But that's not what happens. What happens is we get gamma rays. So what is gamma rays? Well, that's energy. Okay, well, where does that energy go? Well, it goes and it interacts with another particle. Okay, well, now that particle has excess energy. You kind of see what I'm getting at with here, because now, they annihilated, but they didn't annihilate, right? Something still came out of that. And so basically, that right there is the proof we need. That's why there's something rather than nothing, is because they're not actually equal. There is still something there when they collide. They don't perfectly cancel out. And so if they don't perfectly cancel out, those gamma rays go out, and then they interact with another positron or electron or something. And then when those ones interact, they don't perfectly cancel. And so that's kind of just my, I guess, theory on why there's anything at all. And to go further on the point, I want to do a quick Google search here, because I'm pretty sure this is a law, but I want to look it up. Yeah. So a fundamental principle in physics is matter cannot be created or destroyed, right? Well, matter what's happening when a positron and an electron collide? One's matter, one's antimatter. I thought we said matter can't be created or destroyed. I guess that's not a fundamental principle. I guess that's a lie. But here's the thing. If it's not a lie, and it's true, matter can't be created or destroyed, when they annihilate, right, gamma rays are created. Well, where does the matter go? Because gamma rays are light. Light doesn't have mass. But all that's left is gamma rays. And if we know that an electron and a positron do actually have mass, we know even antimatter has mass, right? If they both have mass, then where did that mass go? And, we say mass is energy, and energy is mass, but and so I guess the argument is that, well, it just turns into pure energy. But I don't think you can have energy without mass. I think it's not, oh, it's either energy or it's mass. No, it's just energy and mass. They're the same thing. They're not two sides of the same coin. They're just like, it's still one coin is what I'm trying to say. I don't know. So what I'm trying to say is that I think there's still mass in these gamma rays. And so it's more proof to light having mass and not being massless. And I think that's it. I think that's pretty much my whole argument is, the main thing to take away here is that we don't have perfect annihilations in antimatter matter annihilations. We should, if what the current belief is true. They're not opposites. They don't perfectly cancel out. And, this is like a known thing. We've observed they don't perfectly cancel out. And I don't understand why people didn't immediately say, oh, well, that makes sense. They shouldn't cancel out because we have mass. But it doesn't seem like that was a drawn conclusion, because it would be, it would have been said, from my understanding. So I just wanted to kind of put that out there, that annihilations don't perfectly annihilate. It's more like a deconstruction. The components are still there, but maybe some material was lost along the way, but overall, you still got the pieces. So yeah, that's it. Peace out.